Congratulations for reaching this point in the course. This is now the time for the final project. The goal of this final assignment is to create your own private order book DEX. So what is an order book DEX in the first place? An order book DEX is a trading platform where users can create orders to swap tokens one with another. So the idea is that a user creates a swap order, for instance, token A to token B, and creates that order in a program. Another user can then come, accept that order, and the tokens are swapped, so the first user can come back and receive his funds. What we will do here is we'll create our order book in a private manner, meaning no address will be disclosed, and the buyer won't even know who is buying from, and the seller won't know as well. So let's start with creating our program. We will use the Aleo new command, as you now know, and we'll create an order book DEX. Let's call it order book. Let's go to the folder and open the source file. Okay, so how will we represent those orders in our program? Well, it's simple. An order will be represented as a struct, and this struct will contain the two token IDs from the token registry program. So one token will be sold and will note its ID as sold token ID, and another token will be bought. So let's call it like that. Then there will be an amount that will be sold for this token A, which is U128, as in the token registry amounts are U unsigned 128 bits integers, and we'll have our bought token as well. Okay, now we can introduce two Boolean that will let the user know if the order was accepted or not. So it will be just accepted Boolean, and if the funds were withdrawn or not. Which is Boolean as well. And this struct will be called order. So our order book will just store all those orders in a mapping. Let's just call it orders. And it will take an order ID, which is a field, and associate to it an order. So it will be a field that uniquely represents the order that is given upon creation, and there will be an order associated with it. So now, how do we make sure those orders, when they are created, using a transition that would be called create order? How do we make sure that the privacy of the owner is actually preserved? Well, creating an order will return a record that is defined as receipt to the creator of the order. So let's call that record receipt created, and it will actually just contain an owner and the order ID. So when you have a receipt, this means you have the proof that you have actually created an order, and you can actually use that receipt and burn it to either withdraw the funds when the order has been accepted, or simply remove your order and get your sold token back. So here we need to add another feature. And basically for what is following, you will need to write it yourself as part of the assignment. You will need to verify that the order has not been created yet for that order ID in the async transition here. And you will need as well to transfer the token when creating the order that is sold to the program. So the token, the user creating the program will transfer in this transition using the token registry program. So we'll need to import it. And once the user has called that to transfer the tokens, he will receive his receipt. Then we will need to check that the order data does not exist in the mapping for that order ID. And then we can simply create that order in the mapping. Then there will be 3 more transitions. The first order transition will be the delete order transition. It will simply consume a receipt, and if the order associated with that order ID has not been accepted yet, it will withdraw the fund and update the order as withdrawn true. So you need to check all the Boolean so you're not withdrawing, deleting orders that has been created already. Then we'll have, so this is the second task you have to do, is write that delete order transition. Then you will have to create a withdraw transition for when a transaction, an order has been accepted already. The user must be able to withdraw the fund he bought. And then you will need to write the accept order transition, which another user calls to actually give this bought token amount, which is transferred to the program, so the user can then withdraw it. So you'll need to write all 4 of those transitions in order to complete the assignment. Good luck. This course is now coming to its end. Thank you for following it to the end and for putting up with my French accent. I would like to especially thank Antoine Briand for having made the animations for this course, 3Blue1Brown, who open sourced the library he used, the producing team, EdMotions, my partner at this society, Julien Machal, and the main producer, Aleo, without who this course would have never been possible. Thank you.